Welcome back to ECTRIMS 2012. Today we're going to be talking about progressive MS. Researchers are working on ways of treating this 10% of the MS population. And the good news is they're getting definitive results. Take a listen.
So I think progressive MS is the next frontier. The question is, can we uncouple progression? Can we slow progression? And that's the challenge.
We've been studying the brains of people who have had both secondary and primary progressive MS, who donated their brains to research when they died. And we've made some quite remarkable discoveries. What is happening in the brain that is causing that slow build-up of symptoms that's different from what might be happening during the early stages? They found that there was actually inflammation around the outside of the brain, so white blood cells were accumulating in the tissues that surround our brain. What that means is that inflammation is not stopping, it's changing position. It's moving into the brain and staying there. And that's where all our nerve cells live, the ones that actually control just about everything we do. We also found that there was a loss of the nerve cells themselves, quite a substantial loss of those nerve cells. If you've lost the nerve cells, you lose the function. And we found that the number of neurons lost in those areas was very closely associated with how rapidly MS progressed. So if we can find ways of getting drugs across the blood-brain barrier into the brain space and around the brain itself, we could end up stopping progression in MS, and that's why this research is so important.
Today I presented the result of what's called the MS-STAT trial. So simvastatin is a drug which I think many people will be familiar with. It's used widely in millions of people to lower cholesterol. 140 patients were treated over 2 years in what's called a randomized fashion. So they were treated to either the dummy drug or the real drug, no one knowing what they are on, to see the effect of the drug over 2 years. In both does it improve the MRI scan, but also how does it affect the person clinically? The results from the study are very encouraging because as we all get older, our brain shrinks a little bit. It happens a little bit more in progressive multiple sclerosis. And that was what we call the primary thing we were measuring, to see could the simvastatin, the high-dose drug, make a difference to brain shrinkage. And we're pleased to announce that it does. It reduces that rate by about 40%.
What I bring to the field that might be more novel is this idea of bridging the gap between medical information and rehabilitation interventions. So if we can better understand whether interventions, whether medical or rehabilitative work, then we can try different interventions more quickly so that new things can be developed and put out to the public much faster. So what we've designed is a larger study to look at the efficacy of functional electrical stimulation with cycloergometry. And what we have is a standard stationary bicycle, but we have electrodes put on 3 different leg muscles. And the idea is, can individuals who have trouble with this cycling activity, like progressive MS patients, can they improve their walking by using this device versus passively being pulled around the bicycle? From my standpoint as a researcher, I think there's a lot of room for optimism at this point. Ultimately, I think the combination of building on what rehabilitation interventions are being used in other populations and bringing that to the MS field, I think is going to help people with progressive MS quite a bit.
There's huge collaborations going on between North America, Europe, the MS charities coming together, working together. Lots of clinicians and scientists, patients working together in a unified global way to really kind of tackle this problem of progressive multiple sclerosis.
In our next video, we'll cover the subjects of myelin repair and neuroprotection, which is protecting the nervous system from damage caused by MS. See you then.